Hello and welcome to another tutorial. We are going to continue our very beginning discussion to object-oriented programming. We looked at objects, classes, the concept of interface, and also one of the four pillars of object-oriented programming, which was inheritance. Now let's look at the package. Now, what is a package? If you have done any C++ programming, you know that there is a concept of namespace in C++. And the idea is that in object-oriented programming, or even in C programming, which doesn't have the OOP concept, right? You may have methods, basically functions or classes with the same name, right? And the question is it allowed or not? So if you're not able to restrict the scope of your code, let's say this class, if every class or every function belongs to the global class, right? Then you can't really have more than one unique name for any class or any function. So you can't have a class car in the global namespace or the global scope of your application and then also another car, right? And the reason is that obviously for the compiled languages like Java or C, C++, the compiler has to be able to uniquely identify which types you're talking about, right? Because these languages, Java, C, C++, they are basically a statically typed language. So at compile time, the compiler has to know the type of each variable, right? And then if it sees that the type of your variable is a car, then it has to figure out what are the properties of this car. Sometimes you hear the name attribute, for example. So properties of your class. And again, in Java, in C++ terminology, so the property of your class in an abstract general sense, it's just the data or a state of your class and the actions or behavior, right? This is the concept of object-oriented programming that we talked about. And any object holds data and some behavior, a state, action, right? Now in C++ terminology, data is basically member variables. And then actions or behaviors are member functions, because C++ allows a global scope which doesn't belong to any class or anything. So you can't have a standalone functions, but if a function is inside the scope of a class, it's called a member function, which we will see that in Java terminology. For the data we use and then actions here. For the data we use fields. And for actions or behavior, we use methods. So in Java, because every function has to belong to a class, they decided to, instead of differentiating between standalone functions and functions in a class, which you use member keyword, they decided to just call every function a method. Every function has to be a method, which means every function has to be inside the scope of a class, right? Now in C terminology, basically we don't have object-oriented programming, right? So we don't have any namespace, anything, and then the only scope is the global scope of your code, right? So I mean, in C we do have structs, so you can define your own types, which are structs, which you group data, but you cannot define any method for that or any action on that group of data. So you cannot basically have a struct in C++ that has a constructor or has a method or something inside of it. So a struct in C is just grouping a particular set of data together, hold them together as a user-defined type, right? All right, so then the problem is that, okay, C++ and Java, these allow classes. And as I mentioned before, class, interface, enums, right? These are user-defined types. So these define new types, the types that are not actually built into language, right? In Java, we said that primitive types are built in languages. And then there are some core JDK libraries like a string, right? A string is not a built-in type in the JVM, but it's part of the language, the core library that comes with JDK. And you know that when you run your Java application, the very first thing that JVM does when you launch it, it launches all the core Java based, for example, packages, right? Java.lang, Java.math. Java.lang, you don't need to import anything. So everything from Java.lang will be automatically imported when you run the application. And I believe a string is part of Java lang. Let's look at the package definition. Yes, Java lang. So a string behaves like a built-in type, but it's not a built-in type actually, because it's not a primitive type. It's not built in the language in the JVM itself, but it's part of the core library. So a string is part of a library, but it will be automatically loaded at compile time. That's a given. That's a fact. Therefore, it behaves like it's always available as a built-in type, right? Again, the people who developed the JVM, they didn't have to do this, right? But they decided that, okay, a string is so common. In fact, all the libraries, all the classes in the Java base, in the Java.base module, which is Java lang, these are automatically imported, and all of these are very, very common classes, very things, right? So it makes sense to provide all of them in a way that they will be automatically imported. That's why you can treat the types like a, for example, enum type or a integer wrapper. You can treat these as built-in types. But remember, these are part of the libraries that come with the language, not part of the language itself. Only primitive types are cooked in the language, are part of the language itself, right? Int, double float. So we have user-defined types, but then the question is, if somebody has a car and let's say in my application, obviously Java allows using other libraries, so third-party libraries, a library that other people have developed, and we add them to our project as a jar package, right? So we get the binaries, other people develop their own code, their own libraries, and then they package it as a jar file, and then you just download it and add it to your application, and then you have access to all the classes that are defined in that jar file. Now, if somebody else has defined a car or maybe their own string type, then the question is, when I try to use basically a variable of type a string, how does the JVM know, or how does the compiler know which string class to use? Is it my own definition? Is it the one that is part of the core Java library? It doesn't know if there is nothing to differentiate between them, right? So what I'm saying is that if in my OOP package I create a new class, a string, and this is allowed, so why are we getting, so the reason here is that now the problem is that because I created a string in this package, so what happens here is that here the compiler assumes that I'm referring to a string that is part of this package and not the built-in, right? So that's the first confusing thing, that I can have a class that has been already defined somewhere else, right? So if I put the class in this folder OOP, then the compiler realizes, okay, I'm defining a class, a type. Again, this is a user defined type. It's not part of the language. I want you to really understand this concept that a class is not a built-in type. Even the string that comes with the JDK is not a built-in type into the language. Only the primitives are built-in types. Or primitive arrays. We saw that the primitive arrays, there is no class definition associated with them. Instead, they are built into the JVM itself, right? But obviously object arrays, because the object has to be associated with a class, right? What kind of array of objects you're defining. So anything that is associated with a class, anything that has any type that has a class definition is not built into the language itself. It's part of the libraries, and that's the strength of any programming language. You want to keep your fundamental language, the fundamental features, as small as possible, and then you want to build as many libraries as possible as part of your language. That shows the language that has the most libraries is the most powerful language. That's one of the reasons, for example, Python is very popular, because it has very nice and a lot of libraries. Java also has a lot of libraries. If you have ever used Maven, you know that there is millions of libraries on Maven repository, which is great. You can browse through them and then use a library that works for your application, for your purpose, right? So whenever you try to develop a code, right, an application, always try to search see if there's a library available that makes your life easier. And I guarantee you that if you search like Maven for Java or pip Python index library, for example, then you definitely find some sort of library, or you can just search GitHub. There are a lot of open projects there that you can search and see any of them helps with your code. And I would say 90% of the time you will find a library that is very close to what you need to do, right? So never try to start from zero when you're trying to create and develop a project in Java or Python or C++, any language. Try to first find the libraries. So learning the language is easy in most cases, C++, Java, Python. But you have to learn the libraries that are very common and very popular. So that's the difficult part of conquering any programming language. It's not the language itself. Again, it's the libraries that you have to learn to use them. And you have to be very good at like recognizing which library to use, which library to import, etc. Right? Alright, so when I use this class, then in this class car, now the compiler assumes that this string comes from my package, the OOP folder and string. So it assumes that this variable has this type, but this is the type that I already defined, right? Then the question is, how do I tell the compiler, okay, no, this string is actually the one that comes from the JDK, right? And that goes into the concept of importing basically classes, right? So the idea here is that any class has to have a fully qualified name, and I've briefly basically mentioned this before. So any class, or maybe let me just okay, I'll write it here. Any class has to have a fully qualified name. And in fact, JVM only talks or understands fully qualified names. And that means the fully qualified name tells the JVM where to find that particular class. Remember, JVM or Java compiler compiles every class definition to a separate file. At runtime, when you define a type, the JVM goes and loads that class file into memory so that the JVM understands the properties of that class, right? So, by the way, if I change this name, let's say I'm going to refactor, let's save this first and then refactor, rename. Let's say we rename it to a string 1, and it's going to do the refactoring, and then also it's going, when you use the refactoring functionality, it also renames the name of the Java source file, because we saw that if there can only be one public class in your source code, and the name of that public class must exactly match the name of your source code, right? All right. So what happens here is that let's continue with this. As you can see, Eclipse refactoring also changed the name of the if I go back here, as you can see, the name has changed to a string 1. And again, this is one of the powers of refactoring in your IDE, because it not only renames the name of the class, the source file, it also finds all the instances of this type that you use in other parts, other places in your code, and then renames them, right? Now, if I say this is a string, then the compiler realizes, hey, this is the one that comes with Java lang, a string. And this is where the concept of namespace or package comes into place. Java is a folder, right? And it's called a package. Lang is a folder inside the Java folder, and it's a package. A package is just a folder that holds a group of class files, which typically are related to each other, right? And then a string is the class file or the type that we defined, and we set it, we put it, or the class file is actually inside this folder hierarchy, Java lang, right? And how does the JVM know where to find this? So JVM looks at the fully qualified name, and then JVM looks for the class file to load based on the class path variable, right, at runtime. So it basically class path, right, and then fully qualified name, right? And basically this is because class path is obvious. If I run my Java application, the class path is set to my dev.java, obviously, because in your JDK installation folder, JVM knows that those libraries in the JDK should be there, right? So if you remove those JDK, those class files from your JDK installation folder, then the JVM can't find them. But then for your own types, JVM looks at the class path and then appends the fully qualified name. For example, the fully qualified name for this particular car class is basically my source folder is the root. So I have the it becomes class path, right, / dev_java dot oop.car, right? This is the type. But then dot in that, because the operating system doesn't understand dot, it understands / for example, and then car.class. So this is where the actual file is. And if I right click on my project, go to properties, Java build path, we have the source, projects, libraries. You see we have this class path. So the module path, the JDK comes with the module path. This is something they introduced in Java 9, but the class path is basically right now the default path, right? And let's see, project references, Java editor, Java compiler. So Java doc location, annotation, Java doc, yes. So Java build path, you can see which libraries are associated with your project right now, and the class path. I don't have an external library, right? So fully qualified name is, and then you can check the fully qualified name of your class. If you have a main method here, and then I say sysout. Again, you can use the reflection API, which is something that is more of an advanced topic. But if you just say car.class, class has the meta information of your type of your car, and it tells you where the what is the fully qualified name. And again, the fully qualified name is with respect to the class path. That's the variable that JVM needs to know beforehand, before you're launching your application. And then this is that dev.java is the top folder, so class path / dev.java dev_ oop folder. Inside that there is a car, and this is the type. Car is the type. Car.class is the actual compiled file of this type, right? So JVM knows where to find classes. Now if I rename this back to a string, then the question is, how do I tell this that, remember, a string is a built-in JDK type, so JVM automatically imports it. But I can tell the JVM explicitly which string to use. If I have my own string class, I can say java.lang.string, and this is called the fully qualified name. And it tells JVM here, this type is actually inside this folder lang, which is inside another folder Java. And then JVM knows where the class path is. So it goes to the class path folder and then goes there inside this Java, inside this lang folder, and sees if it can't find a string.class file, right? Now I can say this string is actually, so even if I rename this now to back to a string, refactor rename to my own string class, which is definitely allowed, right? This doesn't affect this part, because now I don't get a compilation error, because I didn't, if I say a string, this says that this is my own type, because I put this string inside the same package that this car class is, and the default types is JVM or the compiler looks in the same folder for the type that you define. If it cannot find it, then you have to tell it where it is, and you can tell it it's into you have to provide a fully qualified name, right? So instead of doing this, I tell because so in the same package you don't need to specify fully qualified name of your type. When you define a variable, you just tell it the name of the type, and then the compiler by default assumes that this type, remember, type here is the name of your class. Any type is associated with a compiled class file, .class file. So when I say this model variable is of type string, the compiler says, okay, I know where this car is. It's inside this OOP package. So I go inside this folder and try to see there is a class file called string.class, and there is. So this type is valid. But then the problem is that this assignment operator is not defined for this string class. That's why I'm getting a compilation error. So the type is fine. So if I remove this equality, this class compiles, because this string, but this string is not a built-in string inside the JDK. This is what I defined in the same package, right? But then the problem is that I have another class string which is inside the JDK, and I want to tell the compiler, hey, actually go and use that string class. Then in order to do that, I have to do a fully qualified name, which means I tell the compiler, hey, go search for this type or the class file associated with this type into a specific location, which is java folder.lang folder.string class. And now if I hover over this, it actually realizes that this string is actually the one that comes with the JDK, right? When you launch your application, the root JDK is appended to the class path. So then when you say java.lang, JVM knows what the class path is, and it is able to find this Java folder, this lang folder, and then the class file that is inside this, right? Again, the default is the same package. Package is just a group of source files, and then when you compile in your bin directory in C++, the folder hierarchy of your binaries, class files, is exactly the same as you do it with the source files, right? That's why in this case sources and classes are more or less you can interchange the ideas, right? Source file or class file, because the way compiler, I think it's mostly ID dependent, or depends on your build too. If you use Maven, the folder hierarchy is a bit different, but in general sense, your source hierarchy, the folder packages, and then the source files inside your package, the hierarchy is more or less the same as your class files after compilation. That's why the best practice is inside each Java file only have one public class and no other class. Then there is a one-to-one match between your class definitions in the source file and then the class files after compilation. And again, remember, each class definition in your source file will be compiled to a separate .class file. So you are allowed to have multiple class definitions in the same source file, but that will generate, for example, multiple class files after compilation. Just be careful about that. All right, so again, so I tell JVM that now if I don't say java.lang string, JVM assumes that this is the class or the type that is inside the same package as my car class. Now what happens if I remove this string and let's say remove it to another package? In Eclipse IDE you just drag and drop, but then you have to be careful that because the fully qualified name of the type changes. But again, use IDE because you don't have to worry about this kind of refactoring stuff. And what happens, Eclipse, your IDE does a lot of stuff behind the scenes to ensure that everything works fine. Now, actually, let's create a new package. Let's call this dummy package. And then I'm going to actually move the string into the dummy package. I don't want to get any compilation error in other classes. So let's hit OK. Eclipse searches to see where we actually use this type of string and then tries to modify everything so that there is no compilation error. So let's wait for this to finish. All right, we still get this error. Now I'm going to remove this import. All right, so at the moment, so we take this string class and moved it to this package folder. And again, at the beginning of the source file, there should be a package declaration, and that corresponds to the public class in your source file. And again, this is another thing that is important, and that's why we only have one public class in each source file, because then you have to associate a package to that public class. And that's the fully qualified name. The compiler knows that when it compiles it, it has to put this string inside this folder, inside this another folder, right? Now this string, now the compiler realizes that, so if you see when I move the string from the original package to another package, the Eclipse IDE actually basically added this line, import. Import means we are telling the compiler, hey, when you hit this line, this type string is the one that is actually imported. This gets precedence. If I don't do this, now suddenly this string becomes the one that comes with the JDK. And again, that's because you don't need to explicitly import the classes or the types inside java.lang. These will be automatically imported, all the classes inside the java.lang. But then if I want to tell the compiler, hey, use the one that is in the dummy, this type string is not the one that comes with the JDK, use my own string class, then I have two options. Option one, so option one is to use the fully qualified name of your type. Could be class, interface, anything. And what this means is that tell the JVM or the compiler exactly where to find this type. So fully qualified name means tell Java C exactly where to find this type relative to your class path, of course. And that means from the type hierarchy of your packages. In my case, it's dev.java, dev_java, for example, right? And then dot eclipse autocomplete is a nice feature, dummy dot string. What this means that now the compiler realizes, hey, this type you actually provided an explicit fully qualified name. This is called the explicit fully qualified name. This has no ambiguity. Why? Because you are never allowed to have two source files in the same package. That's one of the main restrictions. And if you're familiar with C++, that's the same concept as namespaces in C++. So I'm going to stop here. In the next lecture, we're going to dive more into the concept of packages and the equivalent concept of namespace, for example, in C++. I hope you really enjoyed this lecture. Please stay tuned, and I'll see you in the next one.